Hello, I'm Yusuke Morita. I'm here again with my colleagues from the University of Washington. I have a question for you. How has the principle of knowledge organization helped you understand students and their learning?
When I teach introductory English writing courses, I find that my students have so many different ideas about writing. One teacher has taught them that they need to write one way, and others have said that they need to write in a completely different way. So when I teach students certain writing techniques, they don't have an easy way to organize the new concepts I'm introducing in relationship to all of the other disconnected and often conflicting things that they've already learned. To help my students begin to organize and use new knowledge about writing, I first begin by introducing them to the task, what it is that they'll be writing, with some concrete examples of what the end product might look like. Then, as a next step, I teach them new concepts so that in their minds they can organize and recall these concepts as steps along the way to completing that task, rather than beginning with the concepts first and then getting to the task later, or leaving it very abstract, like just calling it a final project and not addressing it until the end of the semester.
In my general chemistry courses, there is often a lot of situations in which two ideas appear to be different to the student, but which actually leverage the same concept. A great example of this is the concept of chemical equilibrium, which is fundamental to the entire field of chemistry. I spent a lot of time building this idea for my students in the context of gas phase reactions. But once we move to reactions that take place in water, many students think it's a completely different type of problem, even though it's really the same thing. It's difficult for them to see how the concepts and mathematical techniques that we use to solve these problems can be used in different kinds of contexts. So to help them make this connection, I try to remind them repeatedly in class that we can use the same approach to solve these different types of problems for reactions in water, just as we did for reactions in the gas phase, or even in other phases that come up. I also make sure to use neutral language, which is to emphasize that this is just a helpful reminder and not a judgment of their knowledge, because I know that they're putting the pieces together as we're talking.
Yes, I see similar situations in my work with faculty where the student's way of organizing what they're learning is completely different from a professor's way of organizing the same knowledge. This is quite common in entry-level, quantitative, problem-solving courses where students often make surface-level connections among problems rather than categorizing them by the underlying concepts. So what can faculty do to help students organize their learning in more productive ways? I see some faculty being more and more explicit about the relationships between problems, about what makes them similar and what makes them different. I also see faculty giving students a list of different types of problems and asking the students not to solve the problems, but to set up the problems and then to figure out what concepts they'd need to use to solve each problem.
In my teaching, I use concept maps to help students organize knowledge. Here, I can show you some concept maps which were drawn by secondary school students. This is a map drawn before a science class. Then this is a map drawn after the class. You can see the ideas were more elaborate and organized in his secondary concept map. In my class at Waseda, I asked my students to visualize their ideas using a similar method. In this method, students brainstorm ideas in groups, write their key concepts on post-its, and then categorize them on big post-its on the wall. Since I started doing this, my students think more deeply, discuss ideas, and organize knowledge more effectively.
What are the key takeaways from our discussion of Principle 2, knowledge organization? First, we want to remember that novice learners organize knowledge differently from expert learners. While expert knowledge organization is dense, interconnected, deep, and theoretical, novices' knowledge organization is sparse, disconnected, and superficial. Second, there are strategies that we can use in teaching that can help students organize their knowledge effectively so that they can retrieve and apply their knowledge when needed. These reflection questions are to help you think about how you can connect the principle of knowledge organization to your own teaching and to your students' learning. We hope that you will consider these questions and discuss them with your colleagues. Number 1, What challenges do your students face in using or recalling particular content in your course? Number 2, how has the principle of knowledge organization helped you understand the challenges your students face in learning this content? And number 3, what teaching strategies could you use to help your students better organize their knowledge of this content? Let's look back at the goals we set out at the beginning of this video. We hope that the principle of knowledge organization has helped you further understand how students learn, that you can now identify strategies to help students better organize their knowledge, and that you've begun to reflect on strategies you can use in your own classes to help increase your students' learning. As before, we hope that this and the other videos in this series will help you take findings from the research on learning and apply it to your teaching. Thank you.